And if we don't, it's fine. We'll finish it tomorrow. But then Thursday, we'll do 221, the start of our next unit. And then Friday, we will take a mini mastery, but we'll probably still have a little bit of class. And do you guys know what else is on Friday? Well, yeah, but what aside from that? That makes it like a really cool, awesome, fun day. Cookout, and it's going to be beautiful weather for the cookout. So we got a cookout on Friday. All right. Hey, I don't know why people are talking. Well, maybe you're talking about the cookout, and in that case, that's probably okay. So as a reminder, you're supposed to have a separate math binder, and you do if you bought everything on the supply list. So that is where your math papers are supposed to be. If you are shoving your math papers in the front pocket of your master binder, or really anywhere in your master binder, you're probably about to get, asked to change that. And by asked, I mean probably forced. So on your own, if you've been doing that, please fix it. If you don't have an extra binder to be your math binder, come see me. I have extra binders. But you should have a 1-inch binder that serves as your math binder. All right, so yesterday we started 212. If you want to get out yesterday's paper, you can. Otherwise, get out a new piece of graph paper. We need to finish checking the 211 answers. Yeah, so get out 211. Sorry, I almost forgot about that. Get out 211 so we can check your answers. So yesterday we checked most of these. Guys, do I need to walk around so we pull out our homework? You need to ask questions if anything doesn't make sense. If we have wrong answers, if we couldn't answer something. So I think we checked most of the front yesterday, or up through 12. So I got to zoom out a tiny bit. So tell me if there's anything that you can't read up here. Back up to the other problems you mean. Eli? Yeah, so 210, figuring out the missing amount of the spinner. We do this subtraction problem where we have to figure out what is 1/3 and 1/8 put together. So to do 1/3 and 1/8, we got to find common denominators. And there's a couple different ways that we could go about this. Question, Eli? This is approximate, so I bet you're closer to the exact. Anytime we see the squiggly equals, it's approximate. And 13/24 is more than 50%. So you're probably right, it's probably 54. Yeah, Dixita? For what?
For that question, I got 45. Get 5 by 6.
What's your denominator?
5 by 6. 56. So I got 45.
Yeah, that's not correct. It's because you're using 11/24, so we should be using 13. Ooh, interesting here. Because we got to make sure we have that common denominator. I think there's probably a math mistake. Because 1/8 plus 3/3. We might need to talk about this. Yeah, double check it on your own first. All right, sorry. On the back. 13 terminates, A terminates, B repeats, C repeats, and D, 250 could turn into 1,000 fairly easily, so it terminates. 14, guys, mean and median is going to continue to be on our masteries for probably a couple chapters and probably the whole year. Remember, mean, we add up everything we have, divide by how many numbers we have. Median is the middle when they're put in order which I put these numbers in order for you on your homework. Like I did it on purpose so we could just like swipe them out and get rid of them. So your median should be 40, because that's because your median, you end up finding two numbers for your median. It's 38 and 42. Hey, Katie. I would probably be listening to the math explanation, not trying to break your finger. Like, it's fun if we're double jointed, but I would love your attention on me. So remember what I said yesterday at the end of class? I'll come back and remind you if I need to. So your median ends up being between 38 and 42, which is 40. Any other questions on the rest of the homework? Yesterday we said these two numbers on the side multiply to get the top number. They add to get the bottom number. Yeah. For 215? Thank you for asking. Everybody look at 215. If it's blank, it better not be when we're done talking. Yeah, we're getting further into the school year. I'm starting to lose patience on people that are just doing nothing. Because pretty soon your stack of nothing is going to be a whole lot of something. So if you have blank papers and you're not asking questions, you're doing it wrong. Thomas has a bag with 7 green, 5 blue, and 4 red. I like color, so I color code everything. Guys, if you're struggling with the math, I would advise get some colors. You have highlighters in your binder, hopefully, or in your backpack. To find the probability of red, which is how we would write it, it's how many red on top over the total on bottom, because that's how we determine or predict the chances of it happening. So we have 4 red. That's what's going to go on top. How many total do we have here? 16? So then, yesterday, and we're going to practice this more today, we were discussing to get this into a decimal, if we don't use a calculator, we got to try to make this into a 10, or into a 100, or into a 1,000. Ooh. Or if we recognize that these numbers can both actually get smaller, we can reduce this fraction into 1/4. So 4/16, they can both divide by 4. So I'm going to say forget this step. If I divide them both by 4, divide by 4, divide by 4, we get 1/4. Which then Lucas said can easily become 100 because it's times 25 on top and bottom. And guys, if you don't understand this work quite yet, you should be writing down every single thing I'm writing down. And now that we are over 100, that is our percent. 25%. Now, red or green, we got to put them together. How many red did we have? 4. How many green did we have? 7. How many total did we have? Wait. How many total marbles? 16. So I'm still building my initial fraction. The top is our red or green, and since it's or, we add them together, because either of those colors will make us happy. So that gives us 11. Actually, I should write this in green. 11 over 16. And does this calculator say that we're not, or does this problem say we're not allowed to use a calculator? So calculator is an option also. What is a fraction telling us to do? Like in a calculator, what would we do? Divide. So we do 11 divided by 16. Guys, remember, like, I'm a fan of a calculator. I am very pro calculator. So 0.6875, that's not how we properly say it, but we'll talk about that in a minute when we start our lesson. And to turn that into a percent, move the decimal 2 places to the right. It is 68.75%. Are there any orange marbles? No. So what's our chance of getting orange? 0. 0. If you want to be particular, you could say 0 over 16. But really, it's just 0. Other questions? Guys, remember what I said yesterday. How you feel is more important than how fast we go. A reminder note, if you didn't have this written down, for the next problem, the diamond problems, the top is the product from multiplication. The bottom is the sum from addition. All right, I think the best thing we can do then is do some more practice to build confidence. So graph paper, either yesterday's graph paper or a new sheet. Guys, I'm excited about the cookout. I just found out today that we still have some money left in the budget, and since you guys raised money so we can do awesome stuff and spend it, we've already got like cookout food taken care of. We've already got like ice cream taken care of, right? So I'm gonna run out to Sam's Club and I'm gonna pick up a bunch of cases of Izzy. So we also have Izzy for the cookout. We're making it like as sweet as possible. The drink, the like, it's not soda, but it's like flavored fizzy water stuff. I can't believe I'm having to explain this right now. Yeah, I thought they were going to be excited, but instead they're just like, you're old. What is Izzy? I bet you guys know it without knowing it. Like what Izzy is. Alright, I should see graph paper on everyone's desk and a pencil in everyone's hand. If you didn't label it yesterday, we're now in 212. So if you didn't kind of make a definitive switch in your notes, it's good to squiggly line or something. You can draw a straight line if you really want. It's just hard to draw straight lines. We're in 212. Sorry, my one got a little funky there. Today's date is 9/22. Yeah. If you want the date. And we are taking decimals. I'm going to try to make this as little to write as possible. So we can just literally draw an arrow. We're doing decimals into fractions. Decimals into fractions. I forget if we talked about this yesterday, but what does deci mean? 10. So, like 10 or by 10 or things involving 10, right? Deci, really what deci is telling us is that we're in a base 10 system. Anyone know why we are in a base 10 system? Yeah, I mean, metric is base 10. You are correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many places do I need to write the first 9 numbers? Just one, right? But as soon as I get to 10, I now bump over and I need a second place to write it. I can get all the way up to 99 before I need to bump over and get a third place. So it's every power of 10. So here's the thing I have seen kids confused by. It's not 10, 20, 30. It's not counting by tens. It's multiplying by tens. So if we remind ourselves, we already wrote this down last week, but this first decimal place, what do we call it? Tenths.
Excuse this interruption, Phoenix. I need Maya Milano to the office. Maya, please come to the office.
The third decimal place? Thousands. And that's probably as far as we're going to go today. This should already be in your notes, actually, from 211. It's good to write it again. But here's our first task. So go ahead and number 219. 219. I'm probably going to write these numbers up on the board bigger because I know some of us have visual issues, myself included. We're going to take these numbers, like the first one we see, 0.19. That's not how we say that. We can say 0.19. It's like when you call your friend by that nickname they don't really want to be called. Like, no. We're going to call these numbers what they're meant to be called. Right? So this first one, let's do it together. If we look at 0.19 and want to call it its actual name that it likes. Layla? Yeah, the first thing we do is actually say the number. So we say 19. And then, I don't know why that kind of reminds me of Nintendo. Then, the second part of its name, its like last name, if you will, comes from the decimal place where it ends. So we end in the second decimal place. So actually I'm going to underline this, make it a bit more obvious. First decimal place, second decimal place. So that's going to be hundredths. I think there's no D. Hundredths. I gotta get that poster up. I got a poster with all the decimal places. It just doesn't want to hang up. Is there a D? Yeah, somebody should double check for confidence. But alright, I'm gonna write out all the other ones. That was A. So you've got A done for you. That was A. So our next one, if you can read this, but I'm gonna go ahead and write them out down below. Oh wait, that's not what we were supposed to do. That's halfway to what we're supposed to do. So this is step 1. Say it by the proper name. Because then that lets us write it as a fraction. And I don't want to use the E word, but I think once we name it correctly, this shouldn't be super hard. I put 19 on top, and what do I put on bottom? A 100. So we are naming it. You don't even have to write this down. With your group, you're naming it correctly, and then you're going to write it as a fraction. There. Yeah, you can group up with other people if you want. I normally say 3 max, but I'll trust you, Layla. You can group up with other people's conversations. Or you can work on your own if you want. C is a very small number. How would you want that much of a pizza? Probably not, right? Oh, why did you relate those two things?
I don't know.
That's a weird relationship.
How much I would have wanted.
So it will help make sense if we reference what we've written down. So why we wrote these down is where the decimal number ends. Like here in this, it ends on the third decimal spot. So even though it starts here, we can go down and where we stop saying its number, that's where we get the last name, the decimal place. Nope. So this spot right here is the one spot. How many ones you have? Well, when you start breaking things up, you can't break up one into one. Right? That doesn't make sense. So if you start breaking something up, in the decimal system, the deci, you break it into tenths. Then if we break each of those tenths, each of those into 10 more, it becomes 100. I gotta run through this to show you guys. Not quite. Alright. For any of us, because one of the, I just tell you guys a lot, because I feel like teachers don't often tell as much as we should. We always make professional growth plans, and one of my growth targets is to go more in depth to make sure that we understand things. So some of you have already figured out that I'm a woodworker, so this will not surprise you that I'm pulling out a bunch of little bits of wood. So when we talk about one, this idea of one, right? We can think about it as just one little thing, but especially since I always talk about pizza, normally our one thing gets cut up. So if instead of thinking of one like this, if I think of one, this is one broken up into tenths. Because the decimal system tells us when we break things, we break into 10. Right? So if I say this is my 1, each of these is a 10. But this is kind of like one-dimensional, two-dimensional, three-dimensional sort of thinking. If instead of this being my 1, my pizza's getting bigger. If this is my 1, these are hundreds. Now hold up. Still, I could look at this section. But now this section, this column, if you will, is how much together? A tenth, because it is 10 100ths. So if I look at the whole pizza, or the whole, right, this shows the second decimal place of hundredths, because compared to the whole object, one of these is pretty darn small, right? What would be the next way to break up if I looked at each of these side cubes, each of these hundredths, and I broke each hundredth into 10 pieces? What's the next decimal spot? Thousands, right? This is your 1,000. So now what we initially thought of like, oh, this is like 1. Well, it could be. But if my whole is this, I don't even need the camera, guys. You can look over here. If this is the 1, this is the whole, right? You thought it was only this big, but it's actually this big. I can break it into 1,000 pieces. And literally, if I take them all apart, I have 1,000 of these baby cubes in this cube. Because there are 10 stacks of 100. So this is kind of our visual representation of if this is our 1 baby cube would be 1,000. So I might ask for some volunteer. I might do random card. Take like 20 or 30 more seconds with your team. Probably at least another minute. Decide these answers. I'll do random cards. Not very. I mean,
Heavier than the plastic ones.
Right?
Definitely sounded heavy when you dropped it on the table.
Yeah, I like being dramatic.
There, that's your restroom.
Yes, we are about to go over answers though, so make sure you check in with a teammate when you get back. Alright. Hey Zeus, you are still not here. Let's leave you a code word so you can get some candy when you come back. Vanessa, give me a color. Teal. Give me an animal. Teal flamingos, Jesus. There you go. Teal flamingos. If Jesus listens to the video and comes back and tells me teal flamingos, I'll give him a piece of candy. But then I'm also gonna make him prove to me that he watched the video and probably answer a couple math problems. So, Farah, how do we say this number correctly? So first off, what is the number? Amanda, please, if you would. 391. And then what decimal place did it end in? The thousands. So guys, the number comes from just what is the number? The denominator. Remember we talked yesterday about the denominator, what it does, tells us how many pieces we've been broken into. So we were broken into 1,000 pieces. That crazy 1,000 block there. Kylie, what about our next one here in green? What is our number?
1,000.
Yeah, 1 to start. Our numerator is 1, and our denominator is, because it's in the third decimal place, thousands. Yeah, Layla and I were discussing, can you imagine being given this much pizza? Which is probably accurate. Dikshita, what about in purple here? How do we say that correctly? Yeah, guys, so again, the number, we don't care about the 0, it's 19, and then where does it end? Thousands. 19 thousandths. So we write it 19 over 1,000. Eli, what about in orange? This one takes us back to a bigger piece of pizza. It ends in the first decimal place, so that is 3/10. Guys, there are no once place, which is confusing because this is the ones place, right? How many ones do I have? But as soon as I break something up, I don't have 1. I have pieces. And in the decimal system, we have to break into 10. And if we break again, we have to break those tenths into more tenths, which become hundredths. Because we have to keep multiplying by 10. Layla, graph, what about in my other kind of darker purple here? Yeah, 524 1,000ths, because it ends in the third decimal place. Questions? Tenths, hundredths, thousandths. Those are mainly the ones we're going to be using right now. So, Jerome is looking at this, and he said, "Oh yeah, we got told how to do this. We look at the number. We look at the number and we name it. And we say it ends in the hundredths place. That must be 73 hundredths." And his friend, you don't read the text on the board. My stories are more fun than the text on the board. His friend comes up to me and he's like, "Dude, nah, we're studying for a test. That is not right. This is not." His friend says, "This is not 73 over 100. Why is it not?" Talk to your group. You can talk to me. Okay, so what do you do instead? What is it instead? Well, what is the fraction instead? Yeah, I didn't say it, but I drew it, right? This line is here. This line exists. It does what the line above the number does, which tells us it is repeating. Eve, can you tell me why this isn't 73 over 100? You what? That's all good. That's why we're doing this together. Antonella, can you tell me why it's not 73 over 100? Because it's repeating, and this would just be just 73, right? And it doesn't repeat. So what fraction is this? Do you know? All good. Vincent, do you know? Fractions can repeat. We saw in our homework last night. Fractions sometimes repeat. It all depends on the denominator. Blank card. Mia, do you know what denominators make us repeat? Pull out your previous page of notes. Nope, pull out your previous page of notes. Pull out your previous page of notes. Share with your teammates. If they don't have theirs, share with teammates. This is why we take notes. In your notes, you should have written down, Layla Davis, that a denominator of what causes repeating? You're not Layla Davis. Layla? 9 or 99 or 999 or 9. That like nines, right? Nines make repetition. Layla, how do you know that I'm using 99 here? How many digits are we repeating? 2. Guys, your reminder, and guys, this is going to be on Friday's mini mastery. I'm not even going to joke around and like cough, cough, hint, hint. This is going to be on Friday's mini mastery. The number of digits repeating is the same as the number of nines we put in the denominator. And because I watched TV last night, I am not crazy. 007 does not make me old. There is a new 007 movie coming out, but it is the conclusion, apparently. So guys, what we did yesterday, that if history, well, I don't know. We put, I'm not going to do this first. We put, this should be in your notes. You should be looking at it now, essentially. I had 7 over 999. And we found out that this is, and I did it better in the afternoon class, so I felt like you guys missed out. So hold on. And no one knows it. It's okay. Alright, so growing up, my dad, when he was growing up, so yes, it makes me old, super into 007. But guys, the thing I need to remind you from yesterday, because this is what I care if you remember, the number on top doesn't really matter. We're going to have that over here. But it's the number of 9s tells us I need to repeat 3 digits. So I have to put zeros in front of my 7. So this becomes 007, 007, 007, 007 forever. So then normally we would actually put the bar at the end. If you guys haven't seen James Bond, it's okay. They're kind of violent movies. The old movies were not as violent. The new ones, we've all gone too far. So practice with your team. What are these going to become in decimal form? What are these going to become in decimal form? I'll rewrite them beside them because I know they're kind of small. No! You may not use calculators. Hey, we already had band class. Thank you very much. They're still up here. I just deleted the image behind it to make it a little cleaner. The new movie is called No Time to Die, which I think is a very 007 thing. There's no time to die. 007's been around for there. So, James Bond was initially a character in a book, to give you a little bit of backstory. Alright, Carmen, what would this one become? And actually, we can say these wrong if you want to. So you can say 0 point. So Carmen, you able to help me out? Remember, you guys can always pass. Aiden? Not here. Franco? All right, we only go 3 passes before somebody's got to help me. What is this number? And how many digits is this telling me to repeat? 2. So we're going to repeat both digits in the 19, and that's it. 0.19. And we put the repeating bar above our 2 numbers. Guys, this is on your homework. It's on the Mini Mastery Friday. I hope we're paying attention. I only got 3 minutes left. All right, I'll start breaking this down for everyone. Isabella, well, yeah, or for B, if you can. Oh, you just need it to go through? Thank you very much. All right, Isabella. Yeah, 0.391, and all 3 of these repeat because there are 3 9s down here. Right? The 3 9s down here. Vanessa, what about our next one here? Yeah, 0.3 repeating. 1 digit is going to repeat. The bottom ones get a bit more tricky, so let's make sure we get these in. Marina. Yeah, we have to repeat 3 numbers, so we have to actually add in a couple zeros in front. So we repeat, I want to write bigger than that. We repeat 0.001. Guys, put the bar above all 3 numbers there. John, what about this one? 524,000. Yeah, we gotta say repeating. So 524 thousandths. Repeating. You know what? Let's go class answer. What is this going to become?
19.
Make sure the bar is above the 0 also. That's critical. Make sure the bar is also including the 0. Because this would be 0.19, 0.19, 0.19. Keeps going. The 0 keeps getting included. Right? That's all the time we got for today. Have a wonderful day, guys. If you're curious about why this happens, 222 is a fun problem. It is a fun problem.